It's Wednesday, the 17th of January 2024. These are the science and space headlines you need to know now. Axiom-3 set for launch within the next 24 hours. The most sensitive radio image of an ancient star cluster ever produced revealed. And a lunar mystery solved. Well, here's something cool to start us off. The recent record-breaking rainfall across much of eastern Australia has had an interesting side effect. It's made for prime astronomical viewing conditions. Outback Astronomy's Linda Nadge in Broken Hill telling ABC News the dust lingering in the air has been absorbed by the water droplets and fallen to the ground as rain, making for some pretty clear night skies once those pesky clouds part. Axiom-3 is set for liftoff to the International Space Station within the next 24 hours from recording, giving flight to Axiom Space's third crewed mission. The primary objective of this mission is to test technologies critical for future long-duration space flights, including the Smart Flight Suit 2, evaluating new materials for radiation shielding developed by Italian racing team Dallara, and investigating upgrades to the anomalous long-term effects in astronauts' radiation detector currently operating on the International Space Station. I'll have a mission update next week. The first private industry flight to the moon with NASA science on board is doomed to crash back to Earth in the coming days, according to Peregrine's owner, Astrobiotic. The fuel leak, which led to the end of the planned soft landing mission, is almost over, but the spacecraft is operating, responding, and stable. But mission controllers are unable to divert the lander's course from our planetary atmosphere. Peregrine was the first private moon lander to send NASA experiments and commercial payloads to the moon as part of the commercial Lunar Payloads Services program from NASA. The aim of the program is to send robotic craft to perform science and technology goals ahead of and during the crewed portion of the Artemis program. NASA's OSIRIS-REx team has cleared a major hurdle to access the remaining sample of asteroid Bennu, with the two remaining fasteners from the sample head finally removed. With just a few more steps to take before the remainder of the sample will be fully visible, photographed and weighed, we just need a little bit more patience before learning the total size of the sample returned from asteroid Bennu. The delay since October came about when curation processes discovered 2 of the 35 fasteners couldn't be removed with the approved tools in the OSIRIS-REx glove box. So they had to design and fabricate 2 new multi-part tools from surgical non-magnetic stainless steel. We'll be in touch with the team here on Talkin' Science once that sample meets the world. A global team of astronomers have created the most sensitive radio image ever of a globular cluster. The globular cluster of tightly packed stars we call 47 Tucanae. The research has been published this week in the Astrophysical Journal, and for more, Dr. Aresh Baraman is beaming in. Doctor, welcome. What is a globular cluster?
A globular cluster is a densely packed collection of stars. We are talking about millions of stars like our sun, all of them very close together within our galaxy. So there are around 100 to 200 of these globular clusters within our galaxy. Some other galaxies have a lot more. And these are very old collection of stars. We are talking about billions of years old. So they are relics from the older ages, from the younger age of our galaxy. So when looking at them, we can learn about the younger age of our galaxy and how stars evolved in that age and how what they show now about old evolution of stars.
Well, this is the most sensitive radio image. What does that mean, and how was it captured?
So what does that mean is that because of all the old age of globular cluster, what happens is that a lot of stars in these clusters have already gone through stellar evolution and have turned into stellar remnants, like neutron stars, which are dense remnant core of stars, or black holes. And what happens is that because of the densely packed environment, these neutron stars and black holes run into other stars and interact with them over time. And these interactions create a lot of immense energy emitted through the cosmos that we can actually capture them either in the X-rays or in the radio because of different processes that they go through. And in radio, we can actually capture beautifully emissions from neutron stars and black holes. So the deeper we look, we can actually find more of them. We can actually understand them better. And so that's the exciting bit, that we are actually learning more about neutron stars and black holes in globular clusters. And how this was captured, we actually used CSIRO's Australia Telescope Compact Array, which is the image behind me. This is from Narrabri on the Gomeroi country in New South Wales. And so we used this observatory. We looked at the globular cluster for about 450 hours of observations over a year, as we just looked at it, and compiled all the data and made an image that was the most sensitive image.
Fantastic. Thanks, Doc. Well, 47 Tucanae is visible with the naked eye and was first catalogued in the 1700s, but it's not until recently, with more detailed imaging, that an incredibly faint radio signal has been detected, which is either a black hole or a pulsar, either of which would be a significant discovery as a first-time observation in a globular cluster. Fascinating stuff. Well, X-rays outlining cold gas clouds have been spotted in the spiral galaxy NGC 4945 by the X-ray Multi-Mirror Mission Space Telescope with the help of NASA's Chandra X-ray Observatory. That gas appears to have ripped through the galaxy when it blasted from somewhere around the central black hole, whose equivalent mass is that of around 1.6 million times our Sun. The gas that has been arranged is the raw material that collapses to create stars, which means that these findings could help scientists better understand how supermassive black holes, which can grow to masses billions of times that of our Sun, influence their surroundings and shape the evolution of their galaxies. Galaxies like NGC 4945 that possess an active galactic nucleus are called active galaxies by astronomers, and while the AGN is brighter than anything else in that galaxy, there are times where the thick dust in the centre is dense enough to partially shroud the light from the AGN, allowing astronomers from faraway planets to peer in and see exactly what's going on. An international team of scientists have discovered a critical reaction that occurred deep below the surface of the Moon around 3.5 billion years ago that caused the exchange of iron in magma with magnesium in surrounding rocks. This changed the chemical and physical properties in one of the three components of magma, called melt, which is made of ions from minerals that have liquefied. The geological mystery was sparked by Apollo-era lunar samples showing rich veins of titanium. So the international team used high-temperature lab experiments on magma to try and replicate the findings. With the mixed methodology revealing a distinctive composition, they can say that this is how the melt and solid magma interacted all those years ago to form those unique high titanium basalts. An exoplanet orbiting inside the habitable zone of LHS 1140 may just contain more water than Earth, despite not being dense enough to be a purely rocky body. That's despite initial guesstimates when it was found in 2017, suggesting as such with a width around 1.7 times that of Earth. Therefore, it either has more water than our planet or its atmosphere is filled with hydrogen and helium. Once the James Webb Space Telescope turns its attention to LHS 1140b, we may be able to get a clearer picture of just what is happening. Well, Trekzone membership gets you in first releases and first details. With a few tiers and a few options, you can help Australia's only science, space and science fiction podcast network pick up the pace in 2024. Facebook, Instagram, X, TikTok and YouTube Shorts all have podcast highlights, so find us where you are. For now, this is Talkin' Science for the 17th of January 2024.